Hey, science class. You couldn't wait to get some more learning, huh, about science. You love science that much? I have something for you right here. We can talk about energy and how energy is used to do work. Now we need energy, but we also can do work as picking up something or any other types of work. We have potential types of energy and we have kinetic energy. Potential is the energy that an atom has due to its shape, condition, or position. We're going to look at different types of potential energy in a few. Then we have kinetic energy. This is energy due to the object having motion. Now notice that I have potential over here in red, stops, not moving. Okay, and I have kinetic over here, green light. What does green light mean? Moving. So when you think of kinetic energy, I want you to think of moving energy. When you think of potential energy, I want you to think of still energy. It's not moving, but it's moving in a way more of on an anatomical level. Let's go to the next slide. We'll see. I'll show you a little more. Where it came through. All right, the different types of energy. We have potential energy, we have elastic potential, chemical potential energy, and gravitational potential energy. Kinetic energy, we have thermal energy, mechanical energy, electrical, and nuclear. We're going to go more. We're going to take it a step further. You want to take a step further? Let's do it. All right. Potential energy. Now, this is energy that an object has due to its shape, condition, or position. You have elastic energy. Okay, just like this. Now, this is energy due to it having a compressed or springy shape, like this spring here. Right now, it has potential. It's still moving. It still has potential moving because the atoms in there are still moving on a very, very slow, but they're still moving. Now, when I compress this spring, now we have elastic potential energy. Because when I let this bad boy go, see, springs goes back to its normal position. Also, another way, I have a hair tie here. Now, if I was to, right now, it has elastic potential energy because right now I did the work, the energy, or the work to pull it, to stretch it like this. But now it has elastic energy. So I'm gonna go just like I'm gonna let it go and see what happens. Ow. Oh. Well, we'll keep moving fast. Oh. Now we're on chemical energy. Now chemical energy is energy that's stored in chemical bonds. Okay? Let's think of like a batteries. There's energy stored in here. Yeah, energy stored batteries. We know batteries. But also food. We have energy stored in food. Now I want you to guess which one of these food items has the most energy. Healthy banana or healthy granola bar, but we also have chocolate, caramel, and other delicious items in here. I want you to guess which one has the most energy. If you guess this granola bar, you are correct. This has more energy because I looked up bananas have on average 105 calories as opposed to this granola bar which has 190 calories. So yes, this has more calories in it. All right. Now, gravitational. Now, gravitational energy is energy that's due to depends on the height and weight of an object. We're going to go more into that in class because I have some nice slides from PowerPoint for that one. But it's basically how an item, how it depends on how high an item is and how much weight it is. And we'll go more in that in class. Let's go and get over to kinetic energy. Yeah. Also, just a reminder, notice how potential energy in red means it's at a standstill. But it's still moving on a minute level, but it's at standstill. Potential energy. Now we have kinetic energy. Green light, we're moving. This energy is moving, my people. Yes, it is. We have thermal energy. Now this depends on the amount of atoms that are moving. Now we have an ice cube where the atoms are not really moving that fast. They're frozen. Then we have water, which are They're sliding past each other. The atoms are sliding past each other. Then you have gas. Gas is everywhere. Gas has the most energy because it has the amount of energy. This has a lot of atoms that are moving. Green light, moving. We also have mechanical energy. Mechanical energy, we can calculate how fast the mechanical energy of an item by calculating its mass times speed squared. So we're talking, they're all divided by 2. So we're talking about speed. We're talking about mass times speed, all divided by 2. That's how we find out the mechanical energy. Now we also have electrical energy. It's flowing. You know, electrical energy is always flowing. We also batteries and electrical energy, but its potential, and because it's not doing nothing right now, standing. It's still red light. Kinetic, green, moving. Electricity is moving. Also, nuclear energy. Nuclear energy, we have fusion and fission. Fusion, you can get a lot of energy, by the way, by nuclear energy. A lot of energy. Fusion is taking 2 atoms together. That's how the sun does it. The sun, there's a lot of fusion going on in the sun. And then we have fission. We're taking one big atom and we're splitting it. That's what's happening at our power plants. But I think that's the game calling me. My people, I'll see you tomorrow, and we'll talk more about energy later. But have a good night, and I hope to see you tomorrow. Have a nice day.